Greetings, Earthlings. As Curious Mark likes to say, you'll need to check his. Curious Mark's YouTube channel. I really like this guy. He's really sharp, and he really likes HP and all things Apollo. Like in the Apollo space mission back in the 60s and 70s. Really cool stuff if you're into that stuff. I'll try to remember to put a link in there somewhere to point to his YouTube. But anyway, I just got through editing part 4. It's being processed right now. And I thought what I'd do is go ahead and get ready for part 5. I have the receiver working. I haven't gotten around to rebuilding the the tone control. I'm going to try to do that this weekend, and hopefully we can get a video of that, because I think I cheated you guys on how to rebuild the volume control and how hairy, but I did learn from the volume control, so I think I'll be able to we'll have a little fun with that there, and hopefully we won't break it. But of course, if I break this substrate, that's no problem, but I'll get a little more detail than that. But what I thought I'd do tonight is go ahead and we'll run through these. I'll show you, we'll try to get a S-curve and a bell curve trace on the scope so you can see what I did. I think I cheated you guys on that, and that would be really cool to watch. And hopefully I can help somebody that was like me, didn't quite understand what was going on. I had to finally get back to the book, go back to the basics, which I learned back in the late 70s. and hadn't really used it. We never had to do anything like that when I worked in the TV shop in Winfield, Louisiana, back a place called Allen's Radio and TV. Never did any. I don't think I even did a television alignment. Honestly, my boss, who's gone now, but my boss I've never seen him do but maybe 1 or 2, and he never really showed me how. And as far as I remember, when I was in vocational school and great school, I mean, I don't think we ever did an alignment. Even if I did, if you don't use it, you lose it, especially me. And then some of the jobs that I've done, I've never done alignments. And when I was, I never did work on any of this kind of stuff. I worked for Motorola. See, I did television repair for about 9 or 10 years. And then I went to work for Motorola for about another 10 years, I think, or so. And we did alignments on that, but it was commercial, FM two-way radios. And they were plus and minus 5 kilohertz. So you wasn't nothing aligning those things there. You really just went in there with a sonad meter and adjusted for maximum sonad, 12 dB sonad. You use that. The transmitter alignments wasn't nothing to them. I mean, it was a completely different animal. And then I went to work for, I worked as a technician in the hospital, but I'm sure didn't do anything like that there. And then I went to work for Time Warner Cable, which was the most harrowing part of my life. God, I hated that place. Still have nightmares about it. The people are idiots. Comcast is idiots. Hate Comcast with a passion. Honestly, I hate any telecom entity nowadays. But anyway, I digress. After I went for Comcast, I went to work for the hospital as a technician. Then I when I left there, I went to work at my present as a broadcast engineer, believe it or not. I can't believe it either. For a chain here in Louisiana, and or a cluster here in Louisiana. I also take care of Vicksburg and also Key West. Yay, hate Key West too. God, I hate Key West. Nothing there. They don't even know how to cook food, honestly, and they pay you 4 times as much as you pay at your house. Anyway, where was I? So I never really had an opportunity, I never messed with anything like this. I restored a little AM radio here and there, I restored my wife's great-grandmother's that, I think it was a Crosley. That thing was really bad. It was a rat or a mouse Kemp and I wound up having to take that chassis completely apart, take all the tube sockets, everything out of it. Everything was riveted in. I had to cut the rivets. It was a mess, and then the band switch was just completely disintegrated. I wound up taking some other wafer switches and making one. It did work. It didn't like working, but we'll never use nothing but AM. Matter of fact, it's been sitting dormant probably now for 5 years. I'm going to bring it back here to the shop one day and clean it out, clean it out and make sure it works and see what I've done wrong. But long story short, I just like to talk, and I hope you guys, I feel like my videos are long compared to a lot of other guys, but I kind of look like it's just me. I have a buddy at work. Me and him always talk, and we always, for a long time, and it's just like I'm talking, like, okay, this is what I'm doing, and this is what we're doing, and we kind of banter, and it's like, and I'm relearning this stuff as well. I'm hoping you guys can come along and learn with me. I know I come across as a hick, and I'm from Winfield, Louisiana, and it's I've got a slang like you wouldn't believe, and a lot of people get put off by that at work, and they want to treat you like you some country bumpkin. Well, I guess I am. I'm very country, and I'm proud of it. I'd rather be country than some of these high-class city folks. But anyway, I digress. I don't mean to insult anybody. Of course, if I don't make somebody mad every day, that I'm doing something wrong. But anyway, I'm really just going off target here. So I never really had a whole lot to do with FM receivers and broadcasts and stuff like this. I had an RCA, or I've got an RCA, little RCA AM FM rig. I don't remember what the model number is, or chassis. But I messed around with the FM, and it's not right. And I played with, tried to do an alignment, and I tried to use my little RCA sweep generator, but since it don't put markers out, it's a pain in the butt. To me, because I'm very OCD, I'm very obsessive compulsive disorder. It's just something that I have to know exactly what I'm doing, or I can't function. I almost think I'm slightly autistic. But now I'm just old and forgetful. So anyway, it's a nice RF signal generator for doing other stuff, especially AM alignments. But for FM, you got to have a marker to tell you where your center frequency is. And I bought a little Eco, and I thought it was the bee's knees, a little Eco 369. Let me see if I can show it to you. This dude. I bought that little dude right there some months ago. It was a basket case. That thing was bad. It was rusted inside and all that, and I did the same thing. I pulled all the components out of it, took it completely apart, and that would have made a hellacious video, and I didn't do it before I decided to get back into video. But I rebuilt it and got it working, but it had a marker generator in it too and all that, but it's dials, and I want precision. So I went back to the RCA, this little RCA right here, little WR50B, which is a fantastic generator, built really well inside, and I haven't done anything to it since I got it, and I've had that thing for years. But still, it doesn't have a marker in it, so I just made an arrangement to buy this Syncor SG80 from work, because I never use it at work. I bought it and it don't do exactly what I want it to do, so I decided I'm going to buy it from him. But anyway, it does what I need it to do. It generates a 10.7 marker, or any marker that I want. That way it allows me, and it interfaces to my scope and detector probe fine. It does everything I want it to do, so it's great for my workbench. So anyway, I'm going to shut this down, and I'm going to get everything lined up, and then we'll start hooking stuff up and see if we can get a trace on this, and we'll go from there. Alright, bring it back. Okay, I decided, you know what, since all my videos are longer than watching I don't know, some stupid show on TV. And that's something else I don't do anymore. I don't hardly ever watch TV. I don't know about you people. I know a lot of people like to watch all these little programs and stuff like that. Sorry, I had to get my viewfinder. You know, like Yellowstone and all that. It sounds intriguing, but honestly, I just can't get into these serials anymore. Now, you put me an old episode of Star Trek on there, man, I'll sit down and watch every bit of it. But I don't like the Next Generation. I'm sorry. I'm a Kirk and Spock and McCoy and Scotty guy. I'm sorry. I love the old Enterprise. I've got a model of it somebody gave me. I love the refit, what they call the NCC-1701 refit that you debuted in the Star Trek The Motion Picture. I think that's the most beautiful starship or spacecraft there is and ever was. I don't really like in the later movies that they blew up the Enterprise, and especially the Undiscovered Country. I don't like. It was an okay movie, but it just seems like the dang producers and all this, they always wanted to pick on the Enterprise. You know, they destroyed in Star Trek, the Search for Spock. You know, the third movie, Search for Spock. They just blew it up. And if you stop and watch that movie, you see so much crap could have been avoided just by if they just thought. You know, like with the female Klingon in the beginning of the show there, you know, she saw the tape of the Genesis, and well, he says, well, you saw it? Yeah, I'm sorry. Blew her ass up. Sorry for my language. Why didn't she just beam over? Then they could blow up the ship. Anyway. All that could have been avoided. You know, they didn't have to blow up the Enterprise. And at the end of Undiscovered Country, you know, that ship was still new. They, you know, Starfleet's calling them, hey, you need to come back home. You know, I know you saved, you know, we don't give a crap what you did, but you need to come home because we're going to decommission your dang ship. You know, and they blew the hell out of it. And here's something else that just bugs me about Star Trek. How did we get from working on the Delmonico to doing alignment to Star Trek? I don't know, but I'm enjoying this. I hope maybe, anyway, bore some people. But Star Trek The Motion Picture, when the Enterprise encountered V'ger. V'ger attacked the Enterprise. Now, remember, V'ger took out 3 Klingon warships with its weapon, lighting weapon, whatever the hell you call it. But when it attacked the Enterprise withstood that with its new shields. Okay, you know, V'ger was packing a hell of a punch, don't you agree? And, you know, it wiped out 3 Klingon cruisers, but it didn't wipe out the Enterprise, which means the shields are pretty damn good, right? So here comes the Undiscovered Country, you know, and, you know, the time that the Enterprise 1701A is bound to have a little bit better shields than the original 1701, right? So it was already, the refit already had great shields, they bound to have made them better. But here you come this little pissy ass bird of prey that could shoot while cloaked and just beat the shit out of the Enterprise. I just really have a problem with that. And everybody wants to pick on the Enterprise. They can't think of shit to make. Boy, I really, sorry about that. I get really passionate about that. I love the 1701, the refit. I love the original version too, the original series one. I love it too. But I really love the refit. I think it's a beautiful spacecraft. I know it's imaginary and geeky, but and I certainly don't like how the what you call that nowadays. I don't like the new Star Trek at all. I don't like the ship. I don't like the people that portrayed you know, our beloved characters. I don't like them blowing up Vulcan because they can't think of a better plot device. And it was really stupid about Nero. I think he was just psychotic. But when they had the drilling rig drilling in a hole in Vulcan, why didn't they just shoot a few proton torpedoes at the damn drill, blow it up, and that would have been the end of the problem? You see, that's just the stuff that gets me. Oh, anyway, I get real passionate about that. Maybe I need to make an episode just talking about Star Trek. This would be a fun discussion. Maybe I need to go live and have a Star Trek discussion. Wouldn't that be cool? Anyway, I forgot what I was doing. Oh yeah, let's go ahead and get the stuff to set up this alignment. I've got my signal generator warming up. We'll get the radio warmed up in a minute. Well, we need a few things. We need some cables for the oscilloscope. I got to dig them out. Okay, so the SG80 gives you a vertical and horizontal input to your oscilloscope. So we need a pair of BNC cables. Got them. Alright. Alright, now we need to couple the signal. Can you still see me? Let me move you over here where you can see me. Now we need to couple the signal from the signal generator, from the SG80 signal output. We need to couple it to the input of stage of the radio. So let me find, where's my little coupling device? Right here. My little coupling device. It's got a little, this actually come from my RCA sweep generator, my WR50B. So, can't see me. Anyway, this is the coupling device from my my RCA WG50, and this is ground. This red here is not capacitor isolated. I think it's a 100 picofarad capacitor in there, so it DC blocks anything from going in the generator. So this is how I'm coupling the RF out from my IF out in this case from my signal generator to the radio. Okay, we got that. Now we need a demodulator. We need a way to get the demodulated signal or detected signal to the back to the SG80. That's where this little dude comes in. This is homemade. Made it myself. Yeah. Can you see that? Hope you can. I can see it on there. It's the 39G, that's 39 Golf 222 detector probe. That is what it's called for in the book. The manual for the Syncor had the detector probe schematic. So I built one exactly how it said to build it. So it has 3 leads. You got a ground, detector, and direct. The detector's got a little 1N947, I think. I'm probably wrong, but this is a diode detector. This right here is a direct, isolated direct. It has a 27K between here and the center tap of this, or the center pin of this RG58 BNC. So that's what we need. Okay? So far we're doing good. Alright, what do we want to do next? What I want to do is we need to mount the radio on my test stand. So, let me grab my test stand. The test stand consists of this little wooden block. I think I showed this to you in a previous video. Hopefully you remember. Let me put you on a little bit different location. You know, you get an idea of what the heck I'm doing. I think that'll work. So basically what I'm going to do, I'm going to take the radio, I'm just going to bring it over here, put it back in the test stand. Well, sometimes I ain't good for nothing, but sometimes I can do something. Support it with my chest. I'm going to use this big old clamp here. And I'm just going to clamp it to the back like this right here. Not too hard. Don't want to bend the case. Okay. Now, see if I'll just telephoto again. You can see what I did. Let's see. That's very simple. Just a little C-clamp. A couple of scrap pieces of wood, screwed it together, and put in a little L. That way I can hold it to the I can hold the radio upright. Do what I need to do. Now, go ahead and hook to the generator, and we're going to do this gorilla style. And when I say gorilla style, this just means it seems to me that was a term that they used to use. Alright, what we're going to do, we're going to go ahead and get all the cables connected. We'll go ahead and warm up the old scope. Turn on my scope. This is my little Textronics 2246 100 megahertz scope. It's we're going to come over here, and we're going to come over here to the mode switch, and we're going to select X and Y. So here's your X input and your Y input. Alright, and then I like this scope because it has some math figures and stuff you can do things with. You can measure certain things. It's really cool. One day I'll get me a digital scope, but I like analog scopes. Anyway, we're coming over here, so this X, we're going to go to, I think, vertical here. And then we're going to take the channel 1, which is the X input, go here to horizontal. So we're good to go there, and then we're going to come up here and we're going to select sweep. Boom. And there's your marker frequency. 10.7. This is your signal levels, if you remember from my last. Alright, now we have the scope going, and let's see. I got my leads backwards. See, I got two traces doing the same thing. I think I have to turn the channel off. Actually, I got it backwards after all. Silly me. I'll get it right in a minute. There we go. There we go. There. I got it now. Now you see all that hieroglyphic looking stuff? That is your markers. That's your 10.7 markers and your multiples of that marker. If you can see that, maybe too much intensity. I have to cut it down a little bit there. There we go. Just turn it. There we go. That is your marker. And if we come up here to your marker height, we'll turn that down. See, there's your marker. That center, this big marker right there. Hang on a second. Let me get my little, this big marker right here is your 10.7. And notice I have it centered on the center gradical right there. So that's what you want to do. You want to get that all set normal. Once you get that normal with position, you don't want to move that because that's your reference. Okay, now we got that done. Alright. So the next thing we want to do is go ahead and take this right here. This is your, remember this is the little isolated cable. Got the little 100 picofarad cap in here. This goes to your RF, IF multiplex output. Just like that. Alright, then we're going to come back over here and we're going to connect the black wire to ground. And we need to stop a minute because I need to show you how this is done. Let me find that. See, third IF. Hang on a second here. I got my glasses on, of course. If you can see that, what I want to do, you can do this two ways. You can go in here, and I'm going to just apply the signal here. I'm going to take this positive lead right here. Actually, I'm going to go right here. See that little capacitor? I'm going to clip my lead around this insulation right here. And that right there goes to... I honestly don't remember. Let's see here. Pin 1. So that actually goes to plate. So I'm taking that signal, just putting it on the plate of the RF amplifier section of the FM stage. And I'm oscillating it like that right there. Can you see? Now, that is how you do it. You do not want to couple directly to any circuit of these radios while you're doing this. A, because of the B plus that's on it, which is the high voltage, and B, it loads the circuit down. So like I'm doing it now, nothing's loaded down. So now we've got to we've got our scope connected right here, and we've got our RF output, RF-IF multiplex out right here. And now we're going to take our FM detector probe, 39G222, which is this dude. Alright, got that done. We're going to have to warm up the soldering iron, because we've got to do a little thing here. And it should be noted that when you're doing this radio needs to be on, and this should be noted that your radio needs to be on and have it on for a while so it will be stable. But we're basically just going to check, see if we can get another response curve, see if we can duplicate it. That's all we're going to do. If you can see, I can't, right here, let me move this out of the way for a second. Right here is the FM discriminator coil, right there. This is your primary right here. This is your primary right here. This is your secondary. Remember, this is your center tap. So let's go back over here a second. These two terminals, where are you? These two terminals right here correspond to here. Okay? That's going to the plate of the third IM amplifier, a 12BA6 labeled V5. Alright, then here's your center tap of the secondary, or the output if you ratio detector. There's your center. I hope you can see that. I can't. There it is. There's your center tap, and then each side. That corresponds to this. That corresponds to this right here, I do believe. And then the other two that's on the outside edge, this one and this one, that's 1,000 ohm, 1,000 ohm, and 100 ohm. So there's you 1,000, 1,000. Apparently the diodes, I never could find them, but I finally realized that these two diodes are internal to the transformer. It took me a while to figure that out. So anyway, it's right here. Just imagine between this diode and this 1,000 ohm resistor right here, there's an interconnection, a little dot, just like that right there. Just imagine that being there, because I don't have a pin handy. And the same thing here, and then this 100 ohm is right here, joins that center. This is your actual center. Okay? In other words, that center right there is this center right here. Okay? And then that junction right there, this 1K connects to a junction there, and this 1K connects to a junction there, which corresponds, as you can see, the 1,000 ohm goes here, so that's that. So the diodes in this coil, which that coil is, as remember the last episode, is tightly coupled to this coil, so there's no phase shift between that. This is the only thing that gets a phase shift. Anyway, where was I? So what we're going to do is we're going to unsolder this stabilizing cap right here. And then we're going to take our detector probe and put it right here. And what that allow me to do is this diode right here coming off this secondary of this transformer, this diode will act as my detector to get our S curve. So that's what we're going to do. We're going to take one end of this capacitor loose, which is, this happens to be right there. So I'm going to put you back on the tripod. And we're going to take that cap loose. Get on there. You know, jerk. Hate jerks. Alright, here we go. We're going to zoom you in there. Give you an idea. I don't even know where the heck I'm at on here. Let's see, right there. There you are. Kind of centered. Now, in case you just like watching people solder, my soldering iron's all warmed up. The reason you want to take this capacitor out because it filters too much and it would severely distort your trace. So we're going to go back here with our detector, our little probe here. Kind of big. I did the smallest box that I had. And we're just going to connect. Right. We'll get an S curve, so we need detection. So I'm going to put it right there. Now let me go back. Let's go back gorilla style on the camera. All about my hand. Oh, ugly hand. So we're right there on that 1K, which is right there. That's where I have my detector, right there. So now everything's ready to go. So let's turn the volume down so we don't get a copyright strike. We're just going to apply power. Hopefully nothing blows up. If something blows up, I'll be sorely mad. As you can hear, it's coming to life. Trying to pick up country stations and all that. We're just going to tune it to the end of the dial to get it away from any interference. Alright. I may have turned the light off. Let me see. Yep. I'm going to have an external light. Hang on. Alright. I don't know if you can hear that buzz or not. Look at that trace. That is these stupid lights. Listen to the listen. Hear that? I hate that. Anyway. Now, see my trace now? Normal. So what we're going to do now is we're going to start injecting. Oh, we hear something. Whoa. There's my curve. See if we can give it a little more signal. See what I'm talking about? Signal level right there. Watch as I increase the signal level. See it flatten out? can't even see your 10.7 anymore, marker anymore. Because the radio's cold, it's drifted a little bit in your alignment. There's your marker right there. Golly. See where it's at? Now the radio's cold, it just got turned on. As it warms up, this will straighten out. But there's my curve right there. That's your marker. And like I say, when this thing warms up, this will straighten out. This is what you want. This is your, in the center, you want to come down to this gradical right here, and which is about your 3 dB point right about there. And the same thing here. And this will, as it warms up, it will be perfectly straight. Let's see if I can, a little bit better visualization. But that is a pretty good little old curve right there. It's a real good representation of it right there. Here we go. That's pretty good. As you see, it's already getting centered as it warms up. It's going to take it a little while for it to warm up. But anyway, S-curve. Let's see if we can get an S-curve. So to do an S-curve, let's turn this light. Let's do an S-curve. Right now we're on, we're right here. That's to do our IF alignment right there. We're going to come and move down to here to get our S-curve. This is the output from this discriminator. And let's see what happens. So we're going to go from there to there. There's your S-curve. As I stated a little while ago, this radio was, I just turned this radio on. So as this radio warms up, it'll straighten up. This is your S-curve. If I adjust that, matter of fact, I'm going to do it against my better judgment. Watch as I adjust. See the marker in the middle, the little squiggly line? That's the marker right there. So now that marker is exactly in the middle of this S-curve. That is what you want. That is the zero crossing point of that discriminator. And that's all there is to it. Now let's go back to the bell curve, as people like to call it. Alright, let's see. Move the position down. There we go. There's my FM response curve right there. A little bit off, but I believe when I aligned this before, the radio had been playing for a while, and this will drift into it. Believe me, it's just because this thing is old and it's got drifting component, but it works great. So that's what the bell curve and the S curve looks like. And that's how you set it up. Really nothing to it. So let's turn this down. Alright. So I get a little more light, which is blinding me. I'm going to come over here and I'm going to turn that off. We're going to disconnect our stuff. Disconnect that. Remember, never connect your equipment to a hot circuit. And always, 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 when you're working on this kind of stuff at home, let's see here, use, by all means, you must have an oscillation transformer. That's what this is. This is an oscillation transformer, variable AC power supply. You must. If you don't, you will get electrocuted or damage your equipment, cause a fire, or get hurt very, very bad. And you have got to have an oscillated AC power supply. If you do not, and you plug this directly into the wall, and then you hook your test equipment to it, this chassis is grounded to one side of this line. When you connect the ground of your test equipment to this ground, bad things will happen. You will damage your test equipment. You will damage this. Possibly, if you have your hand on this radio and you touch that test equipment, you will be electrocuted and you will die, or damage yourself, or hurt yourself. So you must be careful, and you must use the right tools. Use an isolation transformer. It's not if and when. And if you go and buy if you go to eBay or wherever, or whoever, and buy a variac, the variacs will adjust the voltage, and that's what this is. This knob here is a variac, but it does not isolate. Variac is nothing more than an auto transformer, which means you've got a common to the in and the out, first problem, and then your output is also not isolated. It goes through the auto transformer. Basically, a variable auto transformer is all it really is. So there's no isolation in a variac. You have to have an isolation transformer. So there's lots of people out there. Just look up isolation transformer on YouTube, and you'll see 1,000 references to it. But anyway, just that little safety. So anyway, we have it. Listen to that. Got to turn it down. See, that's a station. I'm not sure which one. I think that's tech key. Yep, that's 106. And look, that's my antenna right there. You can't see it, but trust me, I have no antenna. I have no antenna. That's it. That is the quick and dirty thing. Quick and dirty way of how I aligned it. That's how I set my equipment up, how I aligned it. And that bell curve was just like it should be, and I showed you what happens if you increase your signal too much. It will distort your signal and cause all kinds of inaccuracies, and you'll never find a right adjustment. So so take your time, read, find that book that I referenced to in the last video. Read that book before you do any of this. Ask lots of questions. You don't have to ask me. You know, I'm a total dumbass. You don't have to ask me, but there's lots of videos on YouTube. Shango 066 has done a lot of these. He's really sharp on these things. He kind of shames me in some areas, but he knows his stuff. And there's several other ones out there that does this stuff. All you have to do is look for them. And you know, I enjoy this. It's a hobby, but my expertise is electronics, and but there are some things we're rusty on, and you know, there's people better at this than I am, but I don't feel bad about it. But I don't mind learning, and I like relearning this stuff, and I like I mentioned earlier, I like to bring you guys along. And I know I talk a lot, but you know, I just want to reach out and just, you know, and there's a heater. Let me turn that big noisy sucker off. It is 30 degrees outside. Anyway, I thought you guys might like that. As I stated on episode 4, we got to do something with this tone control. That tone control right there has the on-off switch on it. So we're going to have to take this thing apart, take all this stuff apart, and I'm going to have to replace these two sections right here. It's going to take a little work, but I think I can do it. And I'll do that, and we'll try to video that. Let's see, this is going to be episode 5, which will be a quickie. And then maybe episodes, I may combine the episodes, I don't know, but I wanted to record this for you guys because I feel like I cheated you. And yes, this looks like hokey stuff. I'm probably going to go back in here and replace these resistors because I clipped them. That's kind of crappy work. I don't do crappy work, so I'm going to go back in, I'll cut all these things out, and I'll change them with new resistors. So I'll make that look pretty again, and I'll also put this capacitor back in there. Clean that back up. So anyway, that's where we're at. Put my Chinese hobgoblin stick down. That's it. Turn that noisy sucker off. And that's it for this one. That's how I got my alignment. The biggest thing you got to do is take your time. Read about it. Learn and watch people do it. Other people's video. If you've got a fine a rig that you cherish highly, I wouldn't recommend grabbing it and start twiddling diddling on it, which, because you could mess it up irreparably or beyond your capability. So if you can find something cheap that's got similar stuff in it, learn with that. Learn on something that doesn't mean nothing to you. Once you get a hang of it, figure out your test equipment. You got to learn your test equipment. There's limitations. You got to also, first thing you do, if you're going to do this stuff, invest in a good isolation transformer. Something this little this is a little Syncor of. Let me show it to you. I'll show it to you. These are not very expensive on eBay. This is a Syncor. Let's see, PR57. See that isolated output? You want that to keep from killing yourself or to seriously hurting yourself and seriously hurting your test equipment, which you may have bought new scopes and stuff. But your safety comes first, guys. Let's go back to this right here. There's your scale. And let's say here. This is your AC volts out. What's selected, see the AC volts. So if I push this right here, this is line. This is telling me what my line voltage is right there. The lower 121 volts AC. If I select output, telling me what my output is. I have it adjusted to this red line. It says watts leakage set. Well, what you need that for? Well, you push this button. 0 to 1.5 amp scale, 175 watts full scale. So if I come back here on the 1.5 scale, I'm drawing less than half an amp of current to this radio. And at 175 watt scale, you follow this one right here. I'm pulling about 55 watts. That's one thing. If you could draw up to 4 amps, you press this button. And now, right here, is your leakage tester. I have a probe that I got that comes for this right here, and you can test leakage, AC leakage. So if you have a radio or some kind of electronics thing, you can test leakage to it there, and that's a whole something that if you get one of these you can read about. Of course, this adjusts to the output voltage, but also if you're going to work on something, I don't know if you can see it back there, but there's a light bulb back there, and there's going to be another one behind it, and a plug right there, and right there's a big old cord. Well, that is my dim bulb tester. You will need a dim bulb tester. A dim bulb tester means you can plug that into your power supply, and then plug your I got 4 minutes left on my card. You can plug your power supply into your dim bulb, and then your equipment into the dim bulb. And if you have some kind of a short or something like that going on, it will absorb that load and not blow up yourself. Anyway, that's it for this episode here. My camera card appears to be full, so I will talk to you on the next one. And enjoyed talking to you, and y'all have fun. Be careful. Bye.